Dear colleagues, I am glad to present to you our research, a method of detecting bot networks based on graph clustering in the recommendation system of social network by Yelyzaveta Meleshko, Mykola Yakymenko, it's me, and Serhii Semenov. Our research is devoted to study recommendation systems and, in particular, the issue of information security in such systems. Main reasons for information attacks on recommendation systems are the next: marketing campaigns in business, political technology, for example during elections, and information confrontation. To implement attacks on recommendation systems, bot networks are used, since only a certain set of profiles in the system can influence forming of recommendations by their joint actions. Having successfully attacked a social network recommendation system or news aggregator, an attacker can change the content and order of news feed items being displayed for system users. Therefore, the task of identifying and neutralizing botnets in recommendation systems is relevant. In existing studies, to have a detection bot networks means to detect all the bots among user profiles. Since the detection of bot profiles is quite a resource-intensive task, we propose to split the task of protecting the recommendation system from information attacks into two steps. The first one is detection of attack signs, and if signs are found, then the second step is detection and neutralizing of bot profiles. The purpose of this work is to develop a method of detecting bot networks in the recommendation system of social network, which could be used only after detecting signs of an attack to check only those user profiles who interacted with possible attack objects. At first, we observe basic models of information attacks on recommendation systems by means of profile ejection. At the figure 1, there are shown general principle of profile injection attack on recommendation systems with collaborative filtration, when all users are divided into three groups: the usual users unaffected with attack, usual users at whom an attack is directed, and bots attacking the system. A model of bot attacking our recommendation system is given at figure 2. Here, three sets of ratings are selected: ones similar to real users, and ones to decrease or to increase ratings of target objects. Typical models of profile injection attacks are presented in the figure 3. In this work, we are interested in three types of attacks: random attack, average attack, and popular attack. To determine the set of probable goals of the information attack of the bot network by analyzing the trends of ratings of items of the recommendation system, the method was proposed in our previous paper. At this slide, you can see the main steps of this method. To determine the presence or absence of an information attack or the object of the recommendation systems, a set of indicators Q is introduced. And there we have two rules to determine the presence and type of attack on the basis of aforementioned indicators and Hurst index. To solve the problem of identification of bot profiles, we developed a method based on graph clustering and analysis of user actions using the coefficients of distrust. Here it is. On stage 1, we create a set of suspicious user profiles S, in which we place the profiles that gave the target rating RT. On stage 2, we assign to each element of the set of possible targets of the attack capital G, label suspicious, and calculate coefficient of distrust KDI given by formula 1, where capital E RTIG means presence of target ratings RT from user UI for item GJ, and this variable take values 0 or 1. On stage 3, for each pair of users I1 and I2 from set S, we create an edge between them with a label botnet. Graph clustering for subgraph is performed on stage 4. On stage 5, we find largest clusters and consider such cluster or clusters as a possible bot network. And finally, at stage 6, we correct the set capital G after analyzing the user ratings from the subgraph botnet. To test the developed method of detecting a network of bots, we performed a series of experiments. But at first, since there is no information on bot profiles in the available open datasets for testing recommendation systems, it is necessary to create a software simulation model of users and recommendation system items to generate datasets that will also contain bot profiles. Two methods were developed with such a purpose. First, a method for generating the structure of the social graph of the recommendation system, and a method for generating user and bot ratings. Stages of these methods you can see here and here. In general, in the first method, the generation of the structure of the social graph of the recommendation system was carried out on the basis of the Barabashvili-Albert model, which creates scale-free networks based on two conditions: first, growth, and the second, preferential attachment of nodes. In the second method, modeling of users' behavior was performed based on the generation of a dynamic graph users ratings items. An example of possible social connections in the developed model is shown at figure 1, where you can see nodes and edges of our graph. Nodes are users and posts, for example, and edges are types of connection similarity views at all, and the most important of us is recommendations. Example of generating the structure of recommendation system and of the part of the recommendation system database with created ratings in a software simulation model are presented at this slide. And also you can see the typical parameters of the structure of recommendation system, such as average node degree, network diameter, density, average clustering coefficient, and average path length. Also, in the table 1, you can see the next parameters: number of users at the end of the model walk, number of items at the end of the model walk, and precision and recall of preferences prediction. Also, here is root mean square estimation. Results of conducted experiments are presented at this slide. As input data for experiments, we use two sets. Data generated in the developed software simulation model and data for bots generated on the basis of known models of information attacks on the recommendation systems. In the table 1, there are test results of the developed information security subsystem for different attack models and different number of bots and attack targets. And in the table 2, there are test results of the developed information security subsystem for popular attack and different number of targets of attack. On the basis of conducted results, we can conclude that the precision of bot detection by the developed method averaged 0.71 for a random attack, 0.81 for an average attack, and 0.71 for a popular attack. For the developed method at this attack precision average 0.71, recall 0.82, and RMSE root mean square error 0.22. The lowest precision appeared when the target of the attack was single, and such precision equals 0.57. And the highest precision appeared when the number of targets reached 25, 30 pieces, and such precision equals 0.78. That's all. Thanks for your attention.